Hi, everybody. So I rewrote the lesson 18 exit ticket and the homework out since, again, I don't have a working printer. So it may look, obviously, it looks a little different from what I posted. I'm going to go over those answers. So if you haven't completed the exit ticket or the homework, go ahead and pause that video. Scroll down on Dojo. I posted a picture of the exit ticket and the homework so that your child could attempt to do that on their own and then go over the answers with me right now. See if they got it right. See if they got it wrong and where they went wrong. Tessa uses square centimeter tiles to build rectangles with an area of 12 square centimeters. She draws the rectangles as shown below. Label the unknown side lengths of each rectangle, then find the perimeter of each rectangle. Well, it tells you that the area is 12. So in this one, I didn't have to write out all the factors of 12, but I'm going to anyway to show you, sorry, I stand, to show you what these missing side lengths are. So whenever you're writing the factors out, you always start with 1 in itself. 12 is even, so I know 2 can be a factor. Do my upside down rainbow. 2 times 6 is 12. 3, I know that 3 times 4 is 12. And that's it. Because there's nothing in between 3 and 4. So wrong way. So when I'm looking at the rectangles that they already had for me, I'm going to do 1 times 12, 1 and 12, 2 times 6 gives me 12, and 3 times 4 gives me 12. Well, I can draw up 3 rectangles, and they already did 3 rectangles for me. And the first one is long and skinny, and they've given me one side length. That one side length is 12. So if I look down here, the missing side length must be 1, because 1 times 12 is 12. If I look at this one, they've given me one side length being 3. If I look down what I've already done over here, the missing side length must be 4. All right, the next one, they've given me a side length of 6. If I look at my factor pairs, the missing side length must be 2. So I've got all my missing side lengths, but then it said to find the perimeter of each one. So that's what I'm going to do first. Remember what I said about this perimeter being like a fence? If you're going to do a rectangle, you got to go all the way around the rectangle, not just these 2 sides. My puppies would get out and run down the street. So you got to do all 4 sides. Perimeter is the outside of a shape. So what do we know about rectangles? They have 2 sets of equal sides. So if I know that this is 12, I know that this is 12. If I know this side is 1, I know this side is 1. And y'all feel free, kids, to respond like you would normally do in class. Don't just sit there in silence. Be actively participating. All right, so I have 12, 12, 1, and 1. 12 and 12 makes 24. 1 and 1 makes 2. So 24 plus 2 is 26. So the perimeter is 26. What was the area of all of these? The area of all of these were 12, but they all have different perimeters. So the first one was 26. Let's see what the second one is. If this is 4, this is 4, because rectangles have 2 sets of equal sides. If this is 3, this is 3. 4 and 4, I'm going to write it on the inside, make 8. 3 and 3 make 6, and 8 and 6 make 14. So this one had a perimeter of 14. Again, its area is the same as this one, 12. 3 times 4 is 12. 1 times 12 is 12. 2 times 6 is 12. They all have an area of 12, but they all have different perimeters. So this one's 14 centimeters. If y'all want to put that down, that's fine. All right, the next one. 6, if this is 6, this is 6. If this is 2, this is 2. All right, so 6 and 6 make 12. 2 and 2 make 4. 12 and 4 make 16. So 16 centimeters. What do you notice about the perimeters. The long, skinny one has the greatest perimeter, and the one that's has shorter side lengths, the one that's more square-like, has the smallest perimeter. You don't have to go as far around this one that you do around this one. Like I said in the last video, like if you're doing track and field, your track and field coach is going to make you run around this one because they want you to exercise a whole lot. But me, being my lazy self, I'd much rather go around this one because I don't like to run. So the long, skinny one, you're going to have to run farther. It has the greatest perimeter. The one that looks more square-like has a smaller perimeter. You don't have to go around it as far. So that's the exit ticket. The homework, create as many rectangles as you can with an area, of 18. I think it gave you like a little grid paper, but like I said, you don't have to have the grids. The grids are just showing you, a different perspective of looking at it. You can just write in the side links. We don't have to have grid paper to solve this. All right. So 18, and then it said find the perimeter of all of them. So it's the same thing we've been doing. Let's find our factor pairs first so we don't miss anything. 1 in itself. 18 is even, so I know 2 is a factor. 2 times what? 9. I know that 3 can go into it. 3 times 6. The only numbers I have left in between 3 and 6 are 4 and 5. 4 won't go into 18, 4, 8, 12, 16, 20. 5 won't go into 18 because it doesn't end with a 0 or a 5. So that's it. I can do 1 and 18, 2 and 9, 3 and 6. So let's start with 1 and 18. Remember, these rectangles aren't going to look the same. I'm going to make this one real long. 1 and 18. 1 times 18 is 18. 2 is going to be double the 1 and half the size of 18 because 9 is half of 18. 2 and 9. 3 and 6, a little bit longer and shorter. 3 and 6. So I have my three rectangles, but now they want me to find the perimeter of all of them. So again, we got to go around all the sides. So this is 18, this is 18. If this is 1, this is 1. If this is 9, this is 9. If this is 2, this is 2. If this is 6, this is 6. If this is 3, this is 3. And then we just add up all the sides. 18 and 18 make, so let me zoom out, make 36. And if you can't do that one in your head, that's fine. But you could do 18 and 18 and 1 and 1. So 18 plus 1 makes 19. 18 plus 1 makes 19. And then just round it up to 20 and then subtract 2 and get 38. But if you're not following me, you could just write out 18 plus 18 and then 1 plus 1 to the side if you need to. 18 and 18 make 36. 1 and 1 make 2. 36 and 2 make 38. All right, 9 and 9 make 18. 2 and 2 make 4. 18 and 4 make 22. Give me a sum of 22. 6 and 6 make 12. 3 and 3 make 6. 12 and 6 give me a sum of 18. Again, what do you notice about these rectangles? The long, skinny one gives you a greater perimeter because 18 is a really long, big number. The one that looks more like a square has the smallest perimeter. Lastly, draw or estimate to draw as many rectangles as you can with an area of 20. All right. Label the side lengths of each rectangle. Which rectangle has the greatest perimeter? How can you tell? Which one has the smallest? How can you tell? Okay, so let's start with our 20. And again, if you're still struggling to find like factor pairs like we're doing, get your parents to give you some other numbers and just work on finding the factors. It's really going to help you later on to be able to do this quickly, especially like with your 4th grade stuff that's coming up. So 1 in itself, 2 and 10, 3 does not go into 20. But what I'm thinking about, 4 does. 4 and 5. Let me do my upside down rainbows. And there's nothing in between 4 and 5, so I'm done. 1 and 20, give me 20. 2 and 10, give me 20. 4 and 5, give me 20. Why? Area is length times width. Let's draw it out. The 1 and 20 is going to be, and that's looking kind of crazy, I apologize. 1 and 20. I need a pencil, but I don't have my sharpener here. Okay, 2 and 10. It's going to be half the size of 20 because 10 is half of 20. 4 and 5 is going to look almost like a square because it's only off by 1, 4 and 5. All right. I need to figure out which one's got the biggest perimeter and which one has the smallest and how I can tell. I can go ahead and tell you I know which one's going to have the biggest. Okay, do you? Before I even solve it. Which one's going to have the biggest perimeter? If you said this one, ding, 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 you're right. It's the longest and it's the skinniest. I've been saying over and over and over, you got a greater length to cover when it's long like this. Which one's going to have the smallest? If you said this one, ding, 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 it doesn't have as much area to cover. The perimeter is shorter. All right, so let's figure out what the actual perimeters are. If this is 20, this is 20. If this is 1, this is 1. If this is 10, this is 10. If this is 2, this is 2. If this is 5, this is 5. If this is 4, this is 4. All right. 20 and 20 make 40. 1 and 1 make 2. So this one had a perimeter of 42. 10 and 10 make 20. 2 and 2 make 4. 20 and 4 makes 24. And again, you can put centimeters after it because it's set up here as square centimeters. Next, 5 and 5 make 10. 4 and 4 make 8. 10 and 8 make 18. Which one has the greatest? I'm just going to do a little arrow. And I've already explained to you, you can write it out if you want to. The one this is the longest is going to have the greatest perimeter. I can tell by its shape. Which one had the smallest? It was this one because it looks almost like a square. You don't have as much to go around. Imagine running this. I would not want to go all the way down here and then up and then all the way back down here. That's longer. So the longer it is, the greater its perimeter is going to be. And that was all for lesson 18 homework and lesson 18 exit ticket.